Have you ever wondered where all this trash really ends up? In 2023, the city of Madrid collected over 549,000 tons of residual waste. This waste is made up of 40% organic material, and until now, there's been no sustainable solution for it. That's why this waste is sent to landfills or incinerators, like the one at Las Lomas, run by Veolia and Presero. The incoming bags go through an initial sorting process. The waste then moves into a 60mm trommel, a large rotating cylinder with holes that sorts materials by size. Smaller organic matter falls through the holes, while bulkier materials stay on top and continue through the process. This portion moves along a conveyor belt, where various separation systems remove metals and other inorganic materials that can be recovered and recycled. The rest of this stream is incinerated. The fraction smaller than 60mm, rich in organic content, is mainly made up of food scraps and biodegradable matter. Right now, it's taken to landfills at a high cost, causing significant environmental harm. Econward's solution is to take 100% of this material to our facilities and turn it into a valuable resource. At our Rivas plant, the selected organic fraction is dumped into a large bunker. From there, it goes to a crusher to ensure uniform particle size. This allows it to be fed into our thermal hydrolysis equipment, called biomac. Here, thermal hydrolysis sanitizes and homogenizes the biomass. The process preps the material for the next separation stage. The hydrolyzed biomass moves to a flip-flow system, which separates it into two fractions. On one hand, materials larger than 40mm, from which aluminum can be recovered, are sent for incineration due to their high energy content. On the other hand, smaller particle biomass, sanitized and highly capable of producing biomethane, is ideal for use in wastewater treatment plants for biomethane generation. Thanks to this process, we could recover 95% of the waste that incinerators send to landfills. That means only 5% would end up in landfills. At the Gabia Wastewater Treatment Plant, in partnership with Zatir and Canal de Isabel II, we've developed a groundbreaking anaerobic co-digestion project aligned with circular economy principles. The Gavia plant is the first in the world to validate an industrial process patented by Econward, enabling wastewater treatment plants to achieve energy self-sufficiency. For the first time, a wastewater treatment plant is incorporating organic waste into its digesters, waste that previously could only go to landfills. The biomass is carried by a conveyor belt to a pulper. In the pulper, it's mixed and homogenized with treated water from the same plant. This creates a uniform, fluid mixture. During the process, heavy materials like stones, glass, or ceramics are removed. In the next stage, a system called the King removes fibers and plastics. The clean biomass is stored to feed a hydrocyclone. The hydrocyclone separates out sand and small ceramics. Small pieces of glass and eggshells are also removed. The result is a substrate with 99% organic matter. Finally, we have a biopulp ready to be injected into the digester. In this closed system, millions of microorganisms break down the organic matter to produce biomethane, a renewable energy source, and digestate, a useful fertilizer. Integrating biomass with anaerobic co-digestion creates synergy between waste treatment systems. Incinerators, which can't recover organic matter for energy, send it to landfills at a high cost. With biomass, this fraction is redirected to proper treatment, cutting costs and boosting overall efficiency. Landfills stop receiving problematic waste, reducing emissions and leachate. In our tests, we've increased biomethane production by 45%, with plenty of room for further improvement. This process solves a problem for some, reduces environmental impact for others, and generates renewable energy for everyone. Waste that once had no solution becomes a valuable resource. Econward, transforming waste into resources.